let's start from off topic. I would like to say dziękuję serdecznie Gruba IT because yesterday they put me in mine. Like before it, I always hear about mines, more about cryptocurrency or something. And yesterday I spent 3.5 hours in Guido mines here in Katowice. And I would say it's really great. There are really big, like megaton machines, which are drilling walls to get coal. And it was like really child pure happiness to see all this stuff. So if you haven't been there, so you definitely need to go there. So it was amazing, and thank you guys. Let's back to our topic. So we will speak about data lake ingestion checklist. So why I speak about such thing? There are a lot of things that people come up to big data and data engineering from different areas. And they face with problems because they are losing some systematic approach to collect requirements, speak with client, build like some layers, how they need to understand their solution and product. And this is why we will speak about it, like shortly about me. So yeah. Not so shortly, but just put a few points here. So like last 5 years, so I'm working with big data and data engineering. So I have experience with batching, streaming, building data models. The same is like on-premise technologies like Hadoop, and the same is with cloud technologies like AWS, GCP. Yeah, and like, you know, in these 5 years, so I come up that a lot of people are making a lot of mistakes. So when they come up from architecture point of view, so and they don't know data engineering, so they're focusing on some really high-level things. And for them, it's really hard to think about not best practices, but basically problems. So one of the things which is important in our work is that we know a lot of problems with data engineering technologies. And exactly this thing makes us experts. And vice versa, so people, software engineers become data engineers, they are focusing on technologies, but they are not have this like systematic approach, like starting layer by layer, asking proper questions. So yeah, and we will speak about it in a second. Right now I will have a topic. So what is our goal? So in general, so like in simple words, words, to understand what our clients want and give them. Yeah, so they're like quite simple. It sounds simple, but basically collecting all requirements, making all trade-off solution, etc. And give exactly what our clients want. It's hard work, but like I think it's there is something more here. I really like this example. So basically, Henry Ford is a guy who create conveyor of like how to build car and make it cheaper. Before it, like when he was asking clients, etc., what they want, so they were saying faster horses. Right, so basically, if you could give them faster horses, so it will not like resolve their problem. So main problem was that they need something cheap and fast, right? So in the same way, like I think it's really great to think about how we work with our products, etc. That we need to understand what our clients want. We need to understand what they need. We need to show both of these things and help them to choose. It's really hard to do, so there are always some pragmatic problems like time, budget, etc. But like as goal, it's like good thing which make me happy to think it's challenging. And in this case, so not always you will come up that you will give what they need. There could be also problems here, but you could show a way. And it's make us professionals. So let's back to our main goal. Let's speak about ingestion. So I think you've seen similar picture like many times, etc. And it looks quite simple, right? So especially for business people, there is nothing more simple than three-step like sequence. And it's like, let's say, it's relatively easy to do when you have like small number of sources and small number of things. Right, so in this case, like if you have really small pipeline, you could build something like yourself. You could use some technology, etc. So everything is quite simple and doesn't require spend a lot of time on requirements. everything becomes much more messy when you have like Lambda architecture. So you have some batch processing, you have some streaming processing, there are a big number of sources. So quite hard to manage. And of course, it's unmanageable. So if you will start just taking feature by feature, put it one on another, so you will have a mess if you will try to build architecture in such a way. So what to do? How to deal with all this complexity? So first thing, it's like simple one is start from big picture. So the same is if we speak about data lakes. So the same is like picture from satellite, right? So we need to treat our stuff as black box and start from like more high level. We need to understand client motivation. We need to ask like a lot of why questions. And of course, it shouldn't be like why and why and why. So it should be more like understand why clients want this solution. So what problems it will resolve, what are goals he put on it. So here is important part that you could use a lot of architecture techniques. So the same is like quality attribute analysis. The same is like here I put a few interesting things like seek the value in requested capabilities. What does it mean? So basically, it's quite important to be sure that your client is not biased to something, because like he could say one thing, but he needs absolutely another thing. And I will show you example a bit soon. There is another thing like diminish accidental complexity. So it means that when you put one solution to resolve one problem, quite possible that your solution will create a problem in another place. So you need to be really careful when you make some decisions and think about trade-offs. So why I have here number 97? So actually there is a great book, it's called 97 Things Which Every Architecture Should Know. So a big number of small stories about like good practices. So I really suggest to read this thing. Yeah, and let's speak about like small example. So you could have a client which will come up and say that he has large files, so he wants to use Spark. He was on Spark Summit in Los Angeles. He thinks it's really great solution for him, like quite addicted guy. And you could face, while you will start analyze his data, that most of his feeds are really small, right? So in this case, like if you will just follow what he asks, first of all, your Spark clusters will spend much more time to start, even like in comparison to basically process these small data sets. Another one is bad cluster utilization. Just imagine that all these 1,000 flows will run in the same time. Like there could be such case, right? So how much memory you will need to allocate for this stuff? Like huge amount, horrible. So here, like you need to be a bit more open-minded and think. So if we have like two such different things, so maybe we need two different technologies for it. So heavy lifting can be done by Spark. For small ones, you could use something more lightweight, like Flink, Lambdas, etc. So there is a big number of different approaches here. Let's go further. So when we speak about ingestion, so important part is sources. What questions we need to ask? So the same thing, so we need to start from some general things, so not going far in details, otherwise you will be like picked by this detail and you will not have enough time to process all other stuff. So you start from first thing is understand number of sources. Absolutely different thing when we have 10 sources and you have 1,000 sources. Absolutely different approaches, etc. and mindset for it. Why so? In case of 1,000 sources, so using technologies which are code as a configuration, code as workflow, etc., will not work because you will need to have like army of developers which will hate their job because they need to write this small piece of code, right? So creating of operational layer will be much harder. So that's why, like, if you think about thousands of workflows, it's absolutely another approach to think, right? So you need to be sure that in future these workflows will be created and maintained by operational people. So when you have 5, 10, so developers can write it, so it's not a big deal. You could use some UI technologies, etc. How this data will be used? So quite important question. A lot of people are saying that, like, I want to build data lake because I can. So in general, it's like a big problem, etc. And if you could explain your clients that it will like lose of time, etc. There should be some goals, there should be some analytics, I don't know, machine learning, etc. Some specific things. Otherwise, it's just done for fun. Have your client worked with this data before? So sometimes data like requesters and data owners are different people. So in this case, like there could be a lot of problems in starting from politics games, ending with problems with data quality, because this data can be provided in the same time with the same like quality, etc. So if your client already worked with this data, he has also some understanding of what he wants to build on this data, right? So spending time on it will be much more easier. And of course, like plans for scale and growth. So, I mean, you could have quite simple 510 workflows right now, or 510 clients right now, but client has like big plans to have 100 of clients, etc. And he has like some roadmap for it. And of course, using some like not big data technologies would be a valid solution for now, but in future it could be that with scale you need to think in scale. Another thing is sensitive data, yeah. So there are absolutely different approaches regarding, like, we will back to it later, but in general, when we speak about GPDR and other cases, where you need to treat your data absolutely in different way. There are a big number of compliance, you cannot log this data, etc. There are a limited number of people who can take a look on it. There should be some PI hashing or something, like replacing all personal sensitive data in some specific database before it will go somewhere in your data lake. Why so? Because you could have some backup mechanism which will just grab everything, right? And you could quite mess up with this thing. So let's go further. So as far as you have some general picture, so here I was not speaking about technologies or something, right? About data formats or something. So here we start speaking about this thing, like, so about this source of data, like basically what formats should be supported, do they have schema, like if there is no schema, etc. Quite important thing actually. So as far as you don't have schema, like everything looks quite simple, right? So you have some raw data, you put it in raw data, you are treated as some bytes or strings, etc. But of course, if people want to use this data, there should be some schema on read, check, etc., where you will apply the schema. And of course, it creates a number of different problems regarding schema evolution, schema changes, problems with applying the schema, like just some dirty data. So these things you need to keep in mind. Another thing is like metadata. Do you have any like specific columns which mean something more than just part of data? So business dates, timestamp, watermarks, there are a lot of things which can be used for optimizations of your flow as some unique identifiers, etc. Another thing like which I mentioned previously, so source statistics, just to understand size in bytes, like you have different sources, etc. You need to see like whole distribution. Max number of columns, like so for most cases it's like not a problem, like, but when you have 1,000 columns, like 2,000 columns, there are such cases like really wide fact columns, etc. For you should already make some alert for yourself, because like such things like Spark has problems with these things, the same as Hive. So for a lot of databases, like the same as cloud databases, it's quite big limitation. So such things also need to be in mind. So let's continue. So we speak about data, and right now we need to also think about source system. So a lot of cases where people just try to make distinguishes these things. They think more about data, but they don't think about sources itself. So there could be sources could be really like some production systems which has their own clients, and of course you cannot create like some really big load on these things. So you need to think about number of parallel connections for each of it. Use direct connectors if it's possible. So in this case there will be not GBDC streaming of data, but basically preparation of some batch of data which will be like sent in bulk. And of course, like read window, so basically when we could read this data, because there could be hours in which you cannot just connect to a production system, otherwise it could fail. And another thing is like how long this data set will be available. Because like if you will fail, you will have some time to recover, and you need to understand these SLAs. Like for Kafka cases, it could be much more simpler, right? So in this case, you don't need to make raw data on disk before you will do anything. You are quite safe to read because you have much more time. But for some systems, like if you have some file and it will be removed like in 1 day or even like in 1 hour, so it could be a problem. So in this case, like making some raw data backup, some staging backup, etc., will make some sense. And frequency, of course, like, so how often you could get data? So like the simplest one is time-based. If you don't think about like 1,000,001 time zone, etc. But in most cases, it's quite trivial part. And another is like trigger-based. So something is like provide or like trigger you get some file in folder, etc. Also, you need to think about one-time delivery. So you build in some pipelines, and then you need to upload history data, which is like hundreds of gigabytes, let's say, etc. So you cannot use the same pipeline for it. So in this case, like you need to build something new, or be already having some scale solution. And also, this case only God knows when data will come up. Let's maybe stay on this example. So like we have a client, and he come up and says that file will come up every last day of month in specific time in specific time zone. Simple case, right? Like on next iteration, he come up and says that if it will be weekend day, like of course there will be no file. We are not working, right? So you need to take it on next day. Okay, you could like there are some Quartz scheduler, etc., which support such thing, etc. You get new requirement, etc. So if it's holiday in Sweden, so of course you need to wait 1 more day. And of course, it could become much harder and harder. So as a result, we ask to get like some, do you have like whole rules, etc. for this thing? And like I get response that yes. So there is like 100 lines XML from a Tivoli system where you have like big number of rules, dependencies, etc. So the same thing, like if something become really overcomplicated, much easier to go from another side. Like compare this file by checksum, etc. every day without thinking about any rules, etc. So in such way, you could easily like resolve such problems just to look at it from another side. Let's speak about data evolution. So I already mentioned this thing, but like you should really consider this thing because like business is changing. The same is data, the same is sources, etc. So like in any systems, this thing will come up. And using schema evolution, like compatible frameworks, like for example, schema registry, could easily resolve such problems, especially when we speak about some minor changes like adding new column, so forward compatible cases. There's another thing is like how is data changing from source side. So you could have quite popular cases where you have full ingest, like you have small tables, you just keep it every time. So you don't need to think about what you have inside. But of course, if you have quite big table and there is like 100 rows added every day, so reading the whole table will be quite expensive. So for such things, people use incremental load. So basically you need to get in some way this delta and just append it to existing source. There also could be mix, so quite popular that you have number of deltas and then you have quite big data set in the end or start of months. So let's speak a bit more about this thing. So I had a client which was saying that like if I support, if we already implement like for relational databases GBDC connector, so we are fine. We could support like all relational databases in once, like DB2, Teradata, like everything. And of course, like with such thing like incremental uploading, it's quite different. So first thing which you could think is slow change in dimensions. So starting from 2 to 6 type, basically any change is quite easy to identify. So starting from 2, where we speak about some primary key thing, right? So we have append only records, etc. So it's quite trivial. You just keep this last primary key, and you could easily like make new append. The same is actually for next ones where you have additional columns like start date, end date. So there is some valid range of data. So similar approach. So you could just collect all this small, you have some identifiers to find this delta and you could get it, right? So in this case, everything is trivial. it's become much more complex if you don't have such identifiers. Like you have tables which quite big one and it has random updates. What to do? So basically the best thing which you could do is find that there is some tool or there is already implemented connector for capture data change. So in this case, so you don't need to think about all this table itself. You will have stream of updates or changes, etc. So this duality between stream and table is quite popular in streaming frameworks, and here it's also like resolving a lot of problems. So the same is like goes to Cassandra. Like if you have random updates, and of course you don't have this timestamp as some key, etc. I mean, because it maybe doesn't use in this data modeling. So using CDC could resolve such problems. Exactly bad case where there is no such CDC thing, right? So there are a number of libraries, I mean, databases which doesn't support it, or it's in bad state, or you have just old version of it. So in this case, you basically need to have new data, old data, like snapshots. You need to make something like hashing for all columns which you have and make comparison. So it's quite expensive, but like it's alive. Unfortunately, you will not do anything. Idea of this story like that's just saying about GBDC source or increment. It's quite simple when you're just saying it, but there could be like 101 different cases. Let's continue. Let's speak a bit about transformation. So the same thing, like it's important to understand number of transformations. So if you have, for each like data pipeline which you have specific transformations, maybe it makes sense to put this transformation after ingestion. You could like finish your ingestion with just normalization of data, and in this case you have some staging area which and transformation could be applied after it, right? So in this case you could remove this complexity from ingestion process itself. It's important to understand dependencies, right? So if your transformation requires to connect to some separate database, or it requires 20 different tables, so it's quite hard to call this thing one pipeline, right? So the same thing, like it creates a lot of complexity, and you need to try to reduce it as soon as possible. State. So the same thing, like your transformations in most cases should be stateless. So if they are stateful, everything becomes much harder. So just like try to understand like that you have state case or stateless quite important. So things like fan in, fan out. So basically you have, you always think that you have one source and one sink and you are quite fine. So like in real life, so you need to consider that there could be like a lot of inputs, a lot of outputs. Such thing will come up like in any day. And the same is like it makes sense to think, is it possible to split it on 100 flows, or it's like makes sense to make exception and keep it like separately. And like field mapping, so something really simple, like let's take it as example. So if you use schema on read, etc., and use things that from your CSV file or something, you get like some proper column names which you could reuse on next stage, think twice. Starting that there could be some duplication of this field, right? So in CSV file, there is no requirement that your column should be named the same. There could be a lot of words, of course, encoding problem. And like such a simple thing like your column start from number, right? So for Avro, it's already quite big problem. So field mapping on each stage, etc. So even it sounds quite boring and like heavy because like someone need to write all these things, etc. So it will resolve millions of different problems in future, and also it will be good for data catalog in future. So we'll speak about it a bit later. So yeah, so you have your pipeline. We haven't speak about sync actually, but still like you could think that there is something. And on each stage it can fail, yeah? So it's important to think about exception flow. Should you like write wrong data in separate folder? Should you write all data in separate folder? Should you log some data, etc., and just keep processing? So all these things are quite important, and it makes you basically try to write your code in more idempotent way. So in such a way that your pipeline can be reprocessed, etc., and it will not duplicate data or make some mess that you cannot like process anything because there is some blocker. And the same is investigation flow. So the same, do you need to keep this data for investigation because people could take a look and understand why it haven't been processed? So there are a lot of things which you need to think and discuss with your clients regarding this thing. So for example, in our case, we even were building like some simple tables on top of this like dirty data. So in this case, people could have simple SQL interface to just take a look on data. Yeah, about target. So in this case, you already source system for downstreams, right? So everything which we were discussing previously absolutely makes sense. The same is to think what is your clients and how they will use this data. Will you become some part of some pipeline, etc.? Will they use SQL interface? Will they run ad hoc queries, or it will be some automatic processing? So all these things come up on you. Same is like custom partitioning, etc. So like for you, it's much more convenient to have simple partitioning for each flow. So in this case, you have like separate data set as a result. But like for client, it could be not case. They want to have like already their own partitioning, and it will break everything. SLA. So the same is like your clients will come up and say when this data will be delivered. Is it possible to notify about like that we finished successfully and we can trigger someone using through Kafka or something or any other notification system? And like other things. So let's start maybe from data quality. So building like a lot of pipelines without understanding of quality of data, without and by data quality, I mean data rules. So basically, like this column shouldn't have null, or this column should have only such max value or min value. In my practice, I've seen a case where people were parsing Excel files. And of course, some of these Excel files were made by manually. And in one case, people were replacing dot with comma. Like for them, it was not a problem. So Excel was just supporting this format in one file, but not in another. And as a result, so on some downstreams, we get like trillions of dollars, etc. And just making step by step, try to find why it was so wrong, why we get bad calculations, etc. It's quite annoying part because like people will come up to you to ask why it doesn't work. And like, after you will make all these checks, you will go to next level, etc. So as soon as possible, you need to implement data quality rules. And as I said, so it could be connected to data itself, right? So we know our columns, we have new column, we have specific values, etc. Another one is business rules. So like reconciliation of different tables, that we have specific timestamps, that we have number of keys the same as in different tables, etc. So it's quite important thing. So basically, after ingestion, so it's one of the things which in most cases you need to implement. Another thing is data lineage. So people need to understand how your data is moving, right? So otherwise you have 1,000 flows, you have some Uzi or I don't know, Airflow. It's like you have like really big mess. And just to get all this history regarding how it was, how to find something, etc., will be really hard. So in this case, like you separately need to think how to build this relationship with data lineage team. The same is data catalog, as I mentioned. So field mapping, so understanding of which field, who is data owner of it, what is data inside, what is meaning of separate column, its description. Like how to find this data, how to connect this data between different tables. There are a lot of cases where you have like a big number of sources, and this data you have duplicates. Some data come from one stream, another from another, but they have some common root. And without like building all this relationship, you will not find this problem. You will have data swarm, right? So let's continue. So important things is compliance. So I already mentioned it. So there is a number of regulations, and like not keeping it in mind, it's quite big problem. So the same is as I mentioned GDPR. The same is for specific industries like healthcare. You have HIPAA, and there is a number of rules which you need to maintain. So like, if we speak about GDPR, that like personal data could be removed by request in some specific period of time. If you just try to build a quite big data warehouse in your downstreams, etc. So it could be really hard to remove this parts, like one record. So building something separately, which can be a map, like some sensitive data and personal data in separate database, and replace it with some hashes or something, or some like dummy IDs. So in this case, like you still will have this connection, but this data will be much more cleaner. Yeah, and of course integration with monitoring and log management. So without all this stuff, so you are basically doomed. So you will not able to control this thing. Thank you all. Have a nice day.